Welcome to my live channel here on YouTube, and I want us to start a series for WAEC and JAM students. Okay, so let's start. So we're going to start with the concept of indices. Okay, as we all know the basic properties of indices, and I would like to give just some few concepts, some few concepts and basic properties of indices. If you are joining, you're just welcome. If you are joining, you are just so welcome. All right. So there's a relationship between indices and logarithm. Is that taken? So I'm going to be dropping some properties of indices or some rules of indices that will be helping of this study. And so we're going to start with the laws of indices. The laws of indices. So from this word indices refers to the power to exponent, or an index. So one of the laws of indices we're going to be looking at today is let's say we have x here power a, then multiply by x here raised to the power of b. Now when the bases are the same with multiplication sign in between the two terms, then automatically the power are meant to add themselves. So this are the base, the x here at the base, while ab at the exponent, or you can as well call it power. Are we together, guys? So here I now have it to be x. Here a here becomes a plus b. Are you following? Are you following, guys? Good. So this is the base, this is the power, this is the base, and this is the power as well. Are you following? Good. So next now, for rule number 2 that will be helping us in the course of the study is the division properties. If I have a here, x power a divided by x raised to the power of b. By law of indices base, I'm meant to pick one, and when I have this power separated or partitioned by a division sign, then the power here minus themselves. Are we together? If you are coming, you're welcome. The power here minus themselves. So in this case now, let's go for rule number 3. Let's not forget this. Okay, good. I have x raised to the power of 0 is equals to 1. And we all know vividly that any number raised to the power of 0 in law of indices is equal to 1. Exactly? Good. And definitely we should also know that 0 raised to the power of 0 is not equal to 1 as well. So we're going to be dealing with this as we so proceed. So let's go to the negative index. The rule of negative index, we have x raised to the power of -4, or let me see negative a, and this can be written by law of indices. I have 1 divided by x raised to the power of a. Exactly. Good. Now let's not forget that 1/10 according to law of indices is 10 raised to the power of -1, and as well 1 divided by 1. So at this point now, we take the number of zeros here to a negative index. Guys, are we making perfect sense? Are we making sense? That's good. So let's go to rule number 5, by the laws of indices. Now, rule number 5 says if I have x raised to the power of, let's say I have a here and raised to the power of d, equals to x here. Here we have the inner exponent and the external exponent. They multiply themselves. A times d is ad. Is ad. Are we together, guys? Are you following? Good. So let's go to the rule number 6, which is the rule of a fractional index. If I have x here raised to the power of 1 divided by a is now equals to, now this one here, now this is the a root of x. Exactly. So now this can be written the denominator of the index comes here to be here as the nth root of the square root, and here becomes x all raised to the power of 1. Exactly. That's fine. So for rule number 7, guys, I have here to be x here. If I have x to be b divided by a, now I could have this to be written as, I have it to be x, the root of x, this a here happens to be this place, and raised to the power of what? Raised to the power of b. Guys, are we making sense? Are you following? Are you following? So practically and extensively, these are the basic laws of indices, and they are much more important we know them before you proceed. Go let's check out for some ordinary ordinary indices problem. Let's check out for some ordinary indices problem, and let's see how we're going to solve most of them. Are we together, guys? Excuse me, let me check some. Guys, are we together? That's good. That's good. So now let's proceed. Good. So now example 1, under ordinary problem, if we are asked to evaluate, please, this question is very important. If you're writing JAM, if you're writing WIAC, please, it's quite, it's quite necessary we get to understand these questions. That's the power of 1 divided by 3, multiplied by 5 here. That's the power of 2 divided by 3. Then all divided by, 2 divided by what? By 3. Do we get? And the past as well are different. So what do we do here, my guys? Any ideas? This is solution. Now, whenever a question is given to you, don't get scared. Just put down solution, and I assure you, the answer will come. So now, guys, let's move ahead. How do we go about this now, guys? It's quite simple and quite clear. Okay. Right now, this implies I have this 8 here can be expressed as I have it to be 2 raised to the power of 3, which is something that's 8. Then over 3, then multiplied by 5 here. Then power 2 divided by 3, then all divided by this 10 here can be divided to 2, can be separated as 2 times 5, then all is a power of the exponent, which is 3. And this is what we have here. Guys, are you following? Are you following? Yeah. So what next now? Let's proceed. So guys, from here, what do we do next? Now, by law of indices, would come to realize and agree that we have 2 raised to the power of, 3 cancel 3 here. I have just 2 raised to the power of 1 multiplied by 5 raised to the power of 2 divided by 3. Are we together, guys? Then, by law of indices, as we explained earlier, now watch. You see, we gave a rule here, according to rule number 7 by the law of indices. Now, when we have x raised to the power of b over a is equals to the 8th root of x, then all raised to the power of b, right? So when we have that now, we can apply is this, that this power here will definitely have effect on this and on this as well. So we now have 2 raised to the power of 2 power 3 multiplied by 5 raised to the power of 2 divided by 3. Now by so doing, now we are making sense. Are we together? So now let me proceed. I'm going to write it down up here so we can continue extensively. So from here now, guys, I have 2 raised to the power of 1 multiplied by 5 raised to the power of 2 over 3, then divided by 2 raised to the power of 2 over 3 times 5 raised to the power of 2 divided by 3. Guys, are we following? Good. So from here now, by the law of indices, as we have all known, so we can work them hand in hand. So I can divide this as 2 raised to the power of 1 divided by 2 power 2 over 3 by 3 over 5 power 2 divided by what? By 3. Guys, are we making sense? Please, if you are coming, you are just welcome. Please don't forget to follow, to subscribe to the channel, because we'll be bringing exciting math content to you together, guys. Good. So what do we do now? Now by law of indices, we're going to apply law of indices in this very place now. That's how it goes. So here, this is base 2. I'm urged to pick up a single base 2. I have it to be 1 minus 2 divided by 3. Then times, this is 5. I'm picking a single 5. This one's here are the same, so I can have 2 power minus 3, then I have it to be 2 over 3. Is that clear, guys? Good. So therefore, guys, I have it to be so I have it to be 2. This implies I have 2 raised to the power. If I do this one, I'll be having something like 1 divided by 3, then multiply by 2 over 3 minus 2 over 3 is 0. I have it to be 0. Exactly. Are we together? Good. So let's continue. So guys, from here, and I have it to be 5 raised to the power. This is 2 raised to the power of 1 over 3 multiplies. Okay. So the next question.